This is a video about scrambling. We're going to look at census data that shows that men earn more than women, and we want to assess whether it's plausible that that's due to chance. Now, I've already made my census data collection. I've downloaded data, including total personal income. The first step is to establish the effect that we really want to look at. So I'm going to make a graph. I'm going to go to the cases panel. I could have made a table. I'm going to put sex on one axis, and income, total is total personal income on the other axis. And we can see if, for example, I make a box plot and rescale it somewhat, that indeed it looks as if the men earn more than the women. But could that have been due to chance? What we're going to do is assess that using scrambling. The first thing we have to do is to make a measure that actually describes how much more the men earn than the women. There are several different measures we could make. One might be the difference of means, another might be the ratio of means, or we could use the ratio or difference of medians, or something else. So let's go ahead and define the measure. We're going to use difference of means in this video because it's sort of the most straightforward. In order to do that, I'm going to go to the measures panel, and I could do it all in one formula, but I'm going to go ahead and use three different formulas in order to simplify things. First, we're going to define a formula that will figure out what the men's income is, and I'm going to call it MINC, or men's income, male income. A formula for that is going to be, well, we're looking for the mean of the income, so I actually have to type mean, open parenthesis, and down here where it says total personal income, I'll double click that. I could type it, but I'm likely to get it wrong. If I just use this mean of total personal income, that's for everybody. I want just the males, so I put in a comma, and now I'm going to put in an implied filter, sex equals, quote, male. I happen to remember that male is what they use rather than M in the census data. So I click OK, and this is the mean for the male's income. Now I'm going to make the female income, which I will call FINC, and reproduce that. Same basic idea, total personal income, sex equals, quote, female. Female. And now, because I'm interested in the difference, I'm going to make DINC. I could call it anything I want. And this is going to be MINC minus FINC. And that's how much more the average male makes than the average female, which is quite a bit of money. Now we want to see whether this $19,884.70 could have arisen by chance. In order to do that, we're going to scramble the data so that there is no association between sex and income. To do this, I'm going to right-click on the input collection, choose Scramble Attribute Values, and now I get a scrambled collection. At this point, there's a really important step. I'm going to look at the measures in the scrambled collection, and I notice that they have the same values as the measures in the first collection. This is because when I scrambled, I didn't scramble either sex or income. In order to change that, I'm going to look, see, I'm still looking at the inspector for the scrambled collection. I'm going to look way over here at the scrambled panel, and it says, oh, the thing that I scrambled was census year. I'm going to change that and scramble sex. I'm going to scramble attribute values again, go back to the measures. Look, now this measure is only $2,534. Not nearly as much as what we had before. Let's see how much this can vary. I'm going to drag open the scrambled collection a little bit so I get the scrambled values button. Click it, minus 2386, 6599, negative 7176. This means in this case the women earn more than the men. 7605. So these are the numbers we're interested in. Are they ever going to be as big as what we saw in the original collection? Let's find out. We're going to collect measures. So I right-click on this collection, choose Collect Measures. 1, 2, 3, 4, 5. I get 5 measures, and let's make another graph so I can see them. I'll go back over here to the Cases panel. I could have made a table. I'll look at DINC, and here are our 5, and it's in thousands. We're getting nowhere near the almost $19,000, but we don't know really because we haven't made enough measures. So I'm going to put in another 95 measures, going to turn animation off and choose collect more measures. And look at that. You can see these measures building up, and our sort of maximum value is negative 15,000. So we could get 15,000 by chance, like 1% of the time, because I have 100 here. Let's put the true value for our test data onto this graph. In order to do that, I'm going to find out what it is. I'm going to remind myself 19,885. And now in this graph, I'm going to do plot value. I'm going to write 19,885. Click OK. It doesn't even appear because it's so far off the edge. That's where my true value is on this blue line. Here's the distribution of 100 different scramblings. These are what's possible if it's due to chance. It's possible it could get up to 20,000, but it's a really implausible. Less than 1% chance, a lot less than a 1% chance it would be that large.